Hey guys, my name is Varun and I welcome you to another video of We Teach Math. In this video, I'm going to start with the concept of permutations, so I request you all to pay close attention. Now, a permutation is nothing but an arrangement, alright? This arrangement can consist of objects, and by objects you can refer to living things and non-living things, alright? And numbers. And by arrangement of numbers, we refer to a 2-digit number or a 3-digit number or a 4-digit number, etc. And by arrangement of alphabets, we refer to words which may or may not make sense, alright? Such an arrangement of such things is what you call a permutation. Now there are two types of permutations, alright? Permutations where the objects are identical is one type of permutation, right? We can also say that such an object repeats more than once. And the second type of permutation is when each object is distinct or unique, not non-identical, right? By these words, we mean that no two or more objects are identical, right? No object is similar to any other object in an arrangement, right? You can also mean that no object repeats more than once. For such permutations, the number of permutations can be used either by the multiplication principle or by a certain formula, right? This formula can be used in the place of multiplication principle. Alright, so the number of permutations for distinct objects. As I said before, distinct objects are objects which are unique. No two or more objects are identical. We can also say that no object repeats more than once. The number of such permutations is given by the formula n factorial divided by n minus r factorial, where n and r are variables, okay? N is a variable for the total number of things which are used for making the certain number of permutations, alright? And r is the number of things used for each permutation. That is, r is taken from n, alright? What I meant was r number of things is taken from the total number of n things for each permutation. Let me make this easier for you for taking an example, alright? Remember the flag question we did before, where the total number of flags were 5, and for making each signal 2 flags were taken, right? For each signal 2 flags were required. So that means total number of flags which are present for use is 5, and the number of flags for each signal is 2. N is equal to 5 and R is equal to 2. So that means n is any positive number, right? It gives a number of things used in a permutation, and r is the constant number of things required for each permutation of a particular type. What they mean to say is both r and n are constant, right? For each permutation, r is constant and so is n. As I said before, distinct objects are objects that are unique from one another and different. That is, no object among the n object is similar or identical to another object among the n objects. That is, among the n objects, no two or more no object repeats more than once. Alright. On the formula, you might be wondering what do you mean by n factorial. As I mentioned in my previous video, this is a symbol for factorial. Factorial is nothing but a product, and the multiplication starts from any positive number which is given by n. Let us say n is equal to 3. That means n factorial is equal to 3 factorial, right? So the multiplication process starts from 3, and the second number and the next number which is being multiplied to 3 will be less than 1, right? The multiplication starts from n, which is further multiplied by n minus 1, and the product of n and n minus 1 is further multiplied by n minus 2, and so on till the multiplication process ends at 1. For example, 3 factorial is equal to 3 into 2 into 1. 0 is an exemption here. 0 factorial is equal to 1, because 0 a factorial cannot have 0 as its product, alright? So put this into formula in simple words. A factorial is a product of a group of numbers where the multiplication process starts from n, which is further multiplied with numbers steadily decreasing by 1. Like I said, the process starts from n, which is multiplied by n minus 1, their product is further multiplied by n minus 2 and so on, alright? And this process ends with the multiplication of 1, alright? So the multiplication process ends with 1. It doesn't go to 0 or minus 1, minus 2, etc. So now we are going to the other type of permutation. A permutation where the objects or things repeat. That is, two or more objects in a permutation or arrangement are identical, alright? Number of permutations into a total of n number of things out of which p number of things are identical is equal to n factorial divided by p factorial, where p gives the number of times an object repeats, or you can also say that the number of objects which are identical to each other, alright? If one out of the n number of things repeats p number of times, the number of permutations is equal to n factorial divided by p factorial. Now let us say more than one object repeats in a permutation, alright? Let's say k number of objects have repetitions. Get the difference, guys. K is not the number of times an object repeats. K gives a number of objects which have repetitions. K is a number of objects which have identical replicas. It does not give the number of identical replicas. It gives a number of objects which has identical replicas, alright? So number of permutations with a total of n number of things out of which k kinds of things have repetitions, alright? K kinds of things have repetitions. K kinds of objects have replicas. And repeat pk times, alright? This variable gives a number of times that particular object repeats. Where k gives the kind of object, that is first kind or second kind or the third kind, etc. The number of such permutations is given by the formula n factorial divided by p1 factorial multiplied by p2 factorial, etc. till pk factorial, where k gives the number of such objects or pk is the last such object, alright? Apologies. Pk gives the number of replicas of the last object which repeats in the permutation. This is the explanatory note which I gave. If k is equal to 1, this is the first kind. That is, the object repeats p1 times. If k is equal to 2, this is the second kind. The objects repeat p2 times. p1, p2 till pk gives the number of times an object repeats. K gives the number of kinds of the objects which repeat, alright? K gives the number of objects which has replicas. So guys, these are the Ncert examples I'm starting with. First example is, I did not do all the questions, only a few important ones, so that which is enough to get the idea. I believe you can do the rest on your own, which could be direct formula question. Find the number of permutations of the letters of the word Allahabad. If you notice the word Allahabad carefully, you'll find certain alphabets are repeating. The alphabets are A, L, L, A, H, A, B, A, D. So A repeats 4 times and L repeats 2 times. Alright. So that means K is equal to 2. The number of objects which repeats. The number of objects which has replicas in that particular permutation is equal to 2. Alright. Since the number of objects which has replicas is more than 1, we have to use the formula n factorial divided by p1 factorial into p2 factorial till pk factorial, alright? Multiplication process starts from p1 factorial and ends at pk factorial, right? Over here, p1 is equal to 4 and p2 is equal to 2. Bam! The formula is number of arrangements from the alphabets of the word Allahabad is given by the formula n factorial divided by the product of p1 factorial multiplied by blah 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 and hence at pk factorial. that is given by 9 factorial divided by 4 factorial into 2 factorial, right? Moving on to a second question, example 11. How many numbers lying between 100 and 1000 can be formed from the digits between 0 to 5 if repetition is not allowed? Repetition is not allowed. No digit or no object is repeated more than once, alright? Or no object is being repeated. Read the question again. How many numbers lying between 100 and 1000 can be formed from the digits 0 to 5? That means there's a possibility that 0 can be placed in the hundreds place, alright? It's clear we are having a 3-digit number. We have to find the number of 3-digit numbers lying between 100 and 1000. If 0 ends up in the hundreds place, it will end up being a 2-digit number, which we cannot have. We have to eliminate this possibility, right? First one is number of 3-digit numbers from any of the 6 digits, starting from 0 ending at 5. Alright, this includes numbers which are 0 the hundreds place. Alright, now we have number of 2-digit numbers from any of the 5 digits from 1 to 5. Alright, 1 to 5, because the hundreds place has already been filled up, or that is 0. That means now we have 5 options. 0 has been used up, and now we have 2 vacancies, tens place and ones place. N is equal to 5 and R is equal to 2. Similarly, in the first place, N is equal to 6, because we had 6 options starting from 0 and ending at 5, and we had 3 places, ones, tens, hundreds. So N is equal to 6 and R is equal to 3, right? This is the formula for permutation, guys. Basically, it is 6 factorial divided by 6 minus 3 factorial. In short, you can just write small n above capital P and small r below capital P, alright? In short. So guys, always remember to write n PR before writing the actual thing. This is the actual thing and this is the formula. This is short for n factorial divided by n minus r factorial. Write the number of things above capital P and write the number of things for each permutation below the small p. Alright, apologies, below capital P. This is the formula, small n above capital P, which is above small r. Alright, you have to write it this way. So as I said, number of 3-digit numbers from any of the 6 digits from 0 to 5. So according to the number of permutations where repetition is not allowed, that is no 2 objects are identical or no object repeats more than once, the formula is NPR, n factorial divided by n minus r factorial. Over here n is equal to 6 and r is equal to 3. So after writing NPR, you write 6p3. Similarly, for this case, after writing NPR, you write 5p2. So you subtract 5p2 from 6p3. That is, you subtract the total number of permutations where 0 is in the hundreds place from all the number of 3-digit numbers. Alright, from all the permutations of 3-digit numbers where 0 may or may not be included. Alright, so you completely eliminate the possibility of 0 being in the hundreds place by subtracting 5p2 from 6p3. Alright, that is 6 factorial divided by 3 factorial minus 5 factorial divided by 3 factorial. That is 6 factorial divided by 6 minus 3 factorial minus 5 factorial divided by 5 minus 2 factorial. So over here 6 factorial is basically 6 into 5 factorial. Alright, so you take 5 factorial by 3 factorial common. That way you get 6 minus 1. That is 5 into 5 into 5 into 4, that you get 100. Alright, this is my explanation. The arrangement of 3-digit numbers with any of the 6 digits from 0 to 5 also include numbers where 0 is in the hundreds place. Alright, example 022, 033, etc. That these are double-digit numbers. Therefore, to include only 3-digit numbers, that is 0 should not be in the hundreds place. Some other digit other than 0 which is which is in between 1 to 5, starting from 1 and ending at 5, needs to be in the hundreds place. Alright. So for that, the number of permutations where 0 is always in a hundreds place, 0, 1, 1, 0, 1, 5, etc. is subtracted from all kinds of 3-digit permutations from 0 to 5. Number of all kinds of 3-digit permutations from 0 to 5 is given by 6p3. Number of all kinds of double-digit numbers, that is zeros placed in the hundreds place, number of such permutations is given by 5p2. 6p3 minus 5p2 gives 100. So the number of proper 3-digit numbers is equal to 100. The next question is example 14. Find the number of 8 letter arrangements that can be made from the letters of the word daughter so that all vowels occur together. Alright. So the job is to get to make such a arrangement of the alphabets or the word daughter where no alphabet is repeated more than once. It has to be such an arrangement where the vowels are always together. Alright. So there are 2 steps. Step 1 is ensuring that the vowels are together. Alright. Step 2 is making them a part of the permutation. Alright. So here's what we do. The black ink here is meant only for explanations. Alright. So according to multiplication principle, number of ways a job, activity or arrangement can be done is the product of the number of ways of each of its steps. Alright. We have gone through this rule a number of times before. Alright. Since each method results in a unique and distinct singular arrangement, the number of ways or number of methods of arrangements is equal to the number of arrangements as each way or each method. So whether we find the number of ways or whether we find the number of permutations of the alphabets of the word daughter, it means the same. So over here the job is ensuring the arrangement of the 8 distinct or non-identical alphabets of the word daughter where the vowels are always together. Alright. So the job has 2 steps. Step 1 is keeping the vowels together. Right. And step 2 is keeping the vowels group as part of the arrangement and ensuring that the group doesn't separate. The group of vowels doesn't separate no matter what. Alright. So in the word daughter, we have 1, 2, 3, 4, 5, 6, 7, 8. Alright. A and E are vowels. A and E are vowels and we group them and make it as one singular element or one singular unit. Alright. Each non-vowel alphabet is made a separate unique unit and the vowels A and E are grouped together and made into one unit. So the word daughter has a total of 7 units. Alright. Because along with the we have 3 vowels A, U, E. Alright. So along with the non-vowels 1, 2, 3, 4, 5. We have 5 distinct non-vowel elements and A, U, E and 1 distinct element, vowel element. That is a total of 6 elements. Alright. So step 1 is ensuring that the vowels are always together, right, as a part of the permutation. So this is step 2, ensuring A, U, E are one single element and then as a part of permutation is step 2, because step 2 is keeping the vowels group as a part of the arrangement, ensuring the group doesn't separate no matter what. For ensuring that the group doesn't separate, we have to consider the elements A, E, U as one single element. By making it one single element, they are inseparable. Alright. They are inseparable. They are always together. So A, E, U are always together along with the along with the 5 other non-vowel elements. So add the one single grouped element and 5 other non non-vowel elements, we have a total of 6 elements, alright. So the number of permutations of these 6 elements, or the number of ways these 6 elements can be arranged, is 6 factorial, because no vowel can be repeated more than once. So as we fill up each vacancy, the number of options decreases. 6 into 5 into 4 into 3 into 2 into 1, we get 6 factorial, right? So the number of ways elements of or objects can be arranged without repetition, right, is equal to 6 factorial. So the second step is ensuring that the vowels are together. That means we have to find the number of ways vowels can be arranged together, or the number of permutations the vowels can make as a group. Since there are 3 vowels, we get 3 vacancies, alright, and with the filling of each vacancy, the number of options decrease. That is 3, and now it's 2, and now it's 1. 3 into 2 into 1, we have a total of 6 ways, alright. So step 1 is ensuring that the group of vowels are always together and are a part of the permutations of the alphabets of the word daughter. And the other step is ensuring that the vowels are together. We have to find the number of ways the vowels can be put together. So the number of ways a job can be done is the number of ways is the product of the number of ways of each of its steps. Over here the number of ways the alphabets of the word daughter can be arranged without repetition with the vowels together is equal to 4320. That is because 6 multiplied by 720, we get 4320. So the number of ways vowels are together in the 8-letter word is equal to 6 factorial into 3 factorial, that is 4320.